anyways, what we're going to do is we're going to show you what happens when you set these settings in this control board. This is an Acorn board right here, and you can see the massive bunch of wires that I'm using. This is just a bench test. So without further ado, let me show you how it reacts when the settings and the wires are correct. So first thing we got to do is we got to start the Acorn board up. So we're going to plug it in. Okay. Now we're going to watch the board, and before we start the software, you have to wait until you see the heartbeat light clicking off and on. It's that little light right there. You can see it blinks on and off once a second. Once you have that, you can start Acorn. So here's my little Acorn thing right here. Now it's establishing a connection. And here we have it. So the first thing you do every time you start Acorn, you have to press this reset button. And the next thing you do is you push this little green cycle start button. So we're going to do that, and it's going to go through the homing process. So here we go. Right now, that is the Z motor. And as you can see, I have the Z motor is all the way down at the bottom right here. The light is on. I'm going to trigger it. You see the light went off, and now Z motor stopped turning and the X motor is turning. So we're going to go back over here, and here's the X. So I'm going to trigger the X, and you saw the light go off. Now the X is not moving anymore. Now it's going to home the Y. So both of these are Y technically. One of them is Y and one of them is A. So in order to home these, you have to start with the slave limit first, or the homing switch first. So that one that I have is down here. You can see that I have it marked. I get the wire out of the way. You can see that I have it marked S for slave, which, by the way, I don't really like that term, but that's what everybody calls it. And if I call it something else, nobody's gonna know what I'm talking about. So I'm gonna trigger that. You saw the light go off. The two drives are stopped, and now it is disconnected pair from each other. And now I only have one motor running. So that motor is the Y, as you can see right here. The light is on, and when I trigger that, it finishes, and you can see that it's setting the home positions. And there they are. So now the machine is homed. So now what I'm going to do is I have some G code in here already of a program I did a couple of weeks ago. I'm going to press that same cycle start button. It's going to run this program. First, it's going to center the tool on the part, and when I click it the second time, it's going to run. And I'm going to show you that these switches are also going to act as limit switches. So here goes. So it's already in the middle. So that's the starting point where I wanted the program to start. So I centered the tool on there, and now I'm going to click run, and here it goes. So it's running. There's the program running. Now I'm going to go over here, and with my little knife, I'm going to hit this first switch right up here on the top. You're going to see that light go out. And you notice, as soon as I touched it, everything stopped. So let's go again. See, now it went back to the center, and now it's going to run the program again. There we go. So here's the light on X2, axis 2, which is Y. I'm going to touch that with the knife, this knife, and it stopped immediately. So that's a limit. So now we got the tool back in the center to start the job. I'm going to push the cycle start button. It's going to start. And now I'm going to go to the Z, and I'm going to trip that one. See, the light went off, everything stopped. So I'm going to do it again, and there we're in the center again. Start the program over again. And just to be sure that all of these are working, I'm gonna do the S. So here goes. Everything is stopped. And it says up here that the limits have been cleared, because I let go of them, but they all, every single one of them tripped, and it stopped the program, and it stopped the machine, and that's really all you got to do. So let me show you what the settings that I have to do that. I go into the utility, the Acorn Wizard. I'm sure everybody knows how to do that already. These are the input. These are the input settings. So we have in input 1, we have first axis plus limit. Okay. The second one is second axis minus limit. Okay. The third axis is minus limit. Okay. Fourth axis is fourth axis minus limit. Okay. So what that means is the first axis is gonna move in the plus position, or plus direction actually, and it is going to be the Z, which is up there. It's going to go up, and it's going to hit the limit switch that doesn't exist yet, but it will. So when it gets to that limit switch, it's going to stop, and then it's going to go to the second axis, which is the Y axis, and it's going to, no, it's not going to do that. It's going to do the X first. It's going to do the X axis, and then it's going to do the Y afterwards when the X and the Y, the X and the Z are done. So it does the Z first, then the X, and then the Y. So I think there's a setting where you can change it so it does the Y before the X. But it's going to do, it does, right now it's doing the X first, and then after the X is going to run, as you can see, in the minus direction. So the X is going to go to the left of the machine, all the way to the end where the limit is going to end up being. The third axis is also a minus, so that means that the gantry back there is going to come towards me, and I'm over here. So yeah, it's going to go in the minus direction. The slave is also going to go in the minus direction. So that's all you're really going to do in the settings. And then when you wire this thing up, I have all of the limit switches all lined up here. I have the blue, the black, the brown, the blue, the black, the brown, the blue, the black, the brown, the blue, the black, the brown. That's all 4 of these proximity sensors. So each of the sensors also have to have, on the blue, has to be go to common on the Acorn board, which is yeah, right here. The common is right here. There's 2 terminals here on the end of this block that are both common, and you could put it in either one of those. And then the other thing that you have is you have the black wire. Now the black wire is the signal wire. So each one of these individual proximity sensors has to have that black wire go back to Acorn. So the first one that I have here is right here. It's on terminal 1. The second one is on number 2 input. The third one is on number 3 input, and the fourth one is on the 4th input. So you're going to use up 4 inputs for 4 switches. There's no getting around that, from what I understand. The other thing that you're going to need is this brown wire here. I made it brown because that's the same color as the wire that goes to the proximity sensor. It just keeping the colors all the same just helps keep things from being confusing if you have a problem. So everything on the proximity switches is brown, black, or blue. So I use brown, black, or blue in most cases. I don't have all the wire. This is just a bench test, so some of the wires that I have on here for the signal are white. In fact, 3 of them are. But the brown wire is a power wire, and you can see down here that the brown wire is here. It jumps. This is a jumper that goes over to the other. I guess you can see them better over here. So each of those brown wires jumps from the first one to the next sensor, to the next sensor, and to the next sensor. So we have 4 sensors all together. So you got one wire feeding the first one, then it goes to the second one, the third one, and the fourth one. And all that's doing is feeding 24 volts from right here. So that's, like I said before, there's 2 24-volt positive connectors right here, and there's 2 negative or common connectors over here. So you could put this power wire into either one of these. It doesn't make any difference. When I do this in the cabinet, I'm going to end up putting a bunch of these little terminal blocks and tying them all together, and I'm going to put one power from the power supply that I have over here. This is the power supply that I'm going to use, and there's 2 outputs on here. I'm going to use probably both of them, and I'm going to put a wire from the positive on here to the positive over here, and then the other positive I'm going to run it out to one of these terminal blocks, and then I'm going to tie a bunch of them together, and I'm going to use the other ones to feed power to different places that I need 24 volts. So I don't have a mess of wires sitting underneath here. So that's a way to do that, and I think that's the best way to do it. Otherwise, you get a big mess like this, and you don't want a big mess like this, because if you have to troubleshoot something, if something goes wrong, you're gonna tear your hair out and wish you never hooked it up that way. So take my word for it. I've done this before, and it's a real pain in the neck if you don't do this right. And it's not that hard to do. It's pretty easy. The terminal blocks are a little bit expensive, and right now you can see that I have some blue ones and some orange ones. Well, I have other ones coming with the proper colors so that I can land all of the brown wires on a brown terminal block, the blue wires on a blue one, and the black wires on a black one. So that will be helpful here, and it'll make life a whole lot easier, and it'll be very clearly abundant where all those wires go and what they're doing. So it's important to do that. Here's where you tell Acorn how you want to home the machine. So the first thing you have here is automatic homing. The machine seeks switches to home, and we want to do this automatically. We also want to do pairing on the y-axis, because we have 2 motors on the y-axis. So axis 1, which is actually the X, which is the that thing up there, that one is going to go to positive. As you can see, it says M92, and it says a plus next to it. Axis 2 has got a negative next to it. So axis 2 is Y. So we want the Y to come, from back over there, closer over to where I am. So it's going to come to the front of the table. I don't like homing to the back. I think it's a whole lot better if I home it to the front, because it doesn't take so long for the thing to travel all the way to the front when I'm getting ready to do a job. That's the only reason I do that. And then axis 3 is the Z. No, it's not the Z, it's the X. So that's that one there that moves the Z axis back and forth across the machine. That one is going to home to negative. So what's going to happen is that axis is going to go up to the top to wherever I put the switch, and then the x-axis is going to go all the way from wherever it is over here all the way to that end over there, and then the whole gantry is going to come all the way towards me. So it's going to end up over here someplace on this corner of the machine, well, wherever the switches are. So that's how I'm doing it. I don't care how you do it. You can do it any old way you want. That's the way I'm doing it. The other thing is you have this axis pairing setting up here. Right now I'm axis pairing from axis 4, and it's paired to axis 2. Axis 2 is the Y, axis 4 is the A, which is those two motors there. And I haven't been properly marked as Y and Y, but they're both on the Y axis, so that's sort of true. It's a little confusing if you're doing this, and you should mark them what they are. Anyways, I didn't do that. It doesn't matter. I know what's going on. There's also a setting in here so that if you have motors that face each other, and if they do face each other, they're more than likely going to need to turn in opposite directions. So you can set that there. You also want to go down to this paired axis homing and set it on auto squaring. And since the resolution of my monitor is not correct, I need to get another monitor so that this shows up properly. I have the auto axis pair or homing on auto squaring, and right now it's set on 0.025 for the master axis squaring alignment distance. Anyways, that's I think the end of this video. Maybe, I don't know. I got one hell of a mess here. I'm hoping to get a cabinet today to start putting some of this stuff together and clean this mess up. Incidentally, these are my old motors that I am not going to use, but let me just run this program and you'll see how crazy these motors are. So here we go. Okay, that's at 250 inches per minute. Pretty civil right now, but I changed the inches per minute about halfway through this file up to 300. That's 300. The other day I had them running at 500 and damn things were jumping all over the table. I had to slow it down. Anyway, these motors would never go that fast when I had Mach 3, and I still have Mach 3 hooked up to this machine, but I got rid of those motors and I got these nice ones over here. This is what we're going to hook this thing up to. These Clear Path motors. These are NEMA 23 motors. I don't know if you can read that. Maybe you can. They are SDK 2311S-RLN. They're not the highest spec motors, but they're definitely way better than these. And once I get this thing running, I think this is going to run really good. So anyway, that's enough babbling out of me. So I'll see you later. Bye.